Hello, I am Aniket Pandit, Automotive Software Engineer at Vayavya Labs. Vayavya Labs specializes in silicon to system engineering solutions and services. Our expertise covers key areas such as digital twin development, that is virtual ECUs, software in the loop, coverage driven V&V for ADAS AV, cybersecurity and functional safety for automotive, new architecture development for software defined vehicles, and full stack development for embedded systems. Today, we are excited to share our SOAFEE blueprint for cloud to edge test bench for autonomous driving stack validation. Our SOAFEE blueprint demonstrates a practical approach to validate AD stack at scale on the cloud by integrating SOAFEE Evolve, Ataware's OpenADKit with Vayavya's cloud to edge software in the loop middleware. Currently, ADAS AV development depends on expensive, time-intensive, real-world testing that cannot feasibly cover the enormous space of edge case driving scenarios, delaying safety validation and certification. A scalable cloud-native virtual validation pipeline is therefore required to replay and test thousands of scenarios in simulation while preserving behavioral clarity by using the same runtime environment across development, testing, and in-vehicle systems. Leveraging SOAFEE's Evolve provides the containerized Linux foundation needed to deploy the same ADAS AV workloads seamlessly across cloud and embedded ARM hardware. By integrating a complete ADAS AV software stack with simulator inside SOAFEE blueprint, the Vayavya blueprint aims to close the validation gap and enable repeatable scenario-based verification at scale. This architecture diagram illustrates the Evolve bare metal architecture integrated with SOAFEE framework for autonomous vehicle development and testing. The system implements a distributed software in the loop testing approach using separate compute instances for vehicle stack execution and simulation environments. The system leverages OpenADKit as the primary application framework containing Ataware, open source autonomous driving software stack for perception planning and control. Stack server, Vayavya developed a middleware that manages communication, coordination, and data exchange between the simulator and the stack. The above components run on top of the Evolve platform that is running on ARM64 architecture-based AWS Graviton instance. Base system. The simulation runs on Linux-based operating system, specifically optimized for high-performance computing workloads. This ensures efficient handling of complex simulation processes, real-time data exchange, and multi-threaded sensor modeling, all essential for accurate autonomous driving validation. GPU acceleration. The environment leverages NVIDIA GPU acceleration to deliver realistic, graphic-intensive simulations. GPU support enables high-fidelity rendering for cameras and sensors, faster processing of LiDAR and radar data, and smoother real-time performance across dynamic test scenarios. Simulation components. Simulator interface. Vayavya developed a middleware for interface managing data exchange with vehicle stack. Simulator. Core simulation engine providing physics-based vehicle dynamics and sensor modeling. The popular open source simulator Carla in this case. Orchestrator interface. Vayavya developed a middleware that manages test scenario execution, coordination, and result collection. Scenario orchestrator. Execute complex test scenarios and manages simulation test transitions. The popular open source scenario execution engine ESMini runs in the backend in this case. Scenario management. ASAM standard for scenario creation using open scenario XML-based scenario definitions for standardized test case description and execution. Data flow patterns. The integration enables a seamless lockstep execution of the simulation, ensuring data integrity. Sensor simulation. Continuous streaming of simulator sensor data to vehicle stack. Control loop closure. Vehicle stack processes sensor data and sends actuation commands back to simulator. Scenario orchestration. Test scenarios managed and executed through orchestrator interfaces. Performance monitoring. Ground truth data enables real-time performance evaluation. By leveraging SOAFEE's Evolve, the architecture gains a containerized Linux foundation that allows ADAS and autonomous vehicle workloads to run seamlessly across cloud, development systems, and embedded ARM hardware, integrating the complete ADAS and AV software stack with the simulator inside a SOAFEE blueprint. The Vayavya blueprint helps close the validation gap, enabling repeatable, scalable, and scenario-based verification while ensuring consistency across all environments. The process begins by selecting the appropriate test configuration and simulator setup. In this case, we choose the one that has AutoWare running on Evol on top of Graviton instance and Carla running on x86 platform. Next, we configure the sensor suite on the Ego vehicle. This includes critical sensors such as LiDAR cameras, GNSS, and IMU. Next, we select the scenarios to simulate. We are choosing ALKS cut-in scenario. Once a scenario is selected, we initiate the cloud-based simulation setup for AutoWare stack by clicking Run Scenario. As you can see, the AutoWare stack along with the Carla simulator begins to run on the cloud setup. The vehicle switches to autonomous mode and successfully handles a cutting scenario where another car abruptly enters its lane and stops at the signal. As you can see, you can integrate sensor models, the AutoWare stack, and the Carla simulator to create complete cloud-to-edge setup for scalable cloud simulation. This solution enhances the confidence of stack developers in deploying their software safely and reliably on real vehicles. Through this initiative, we aim to address critical challenges in the verification and validation of automated driving systems. We are honored to contribute as an active member of SOAFEE community, collaborating closely with various working groups, and are proud to announce the release of our first SOAFEE blueprint.